Hello, am I audible, guys?
Yes, you are.
Yes.
Okay, so should I speak in English, Marathi, or Hindi? Is Hindi okay with you all, or should I continue in English?
Fine.
Okay, ओके तो मैं हिंदी में ही बोलता हूँ ताकि सबको समझेगा। ओके सो हम एरएस से स्टार्ट करेंगे अभी। सो लेट्स तो मैं क्या करूँगा अभी कि जो बेसिक कॉन्सेप्ट्स हो गए उसका सिर्फ एक 5-10 मिनट में रिवीजन कर लेंगे हम, और फिर उसके बाद क्वेश्चन सॉल्व करेंगे। तो हम एरे से डिक्लेयर करते हैं एरे ऑफ एन, और फिर ऐसे इनपुट लेते हैं। तो हम्म तो अगर हमने n की वैल्यू 10 दी तो हमें मतलब एरे में 10 एलिमेंट्स को इंसर्ट करना पड़ेगा। तो लेट्स डू दिट। ओके सो हमारे एरे में 10 एलिमेंट्स है। तो लेट्स पहले हम क्या करेंगे, लीनियर सर्च का एल्गोरिदम देख लेते हैं। तो सो ओके सो हम अभी यूज़र से एक नंबर लेंगे और वो नंबर हमें सर्च कर रहे हैं एरे में। तो लीनियर सर्च में क्या होता है कि हम स्टार्ट टू एंड सिर्फ देखते हैं कि वो मतलब एलिमेंट हमको मिलता है कि नहीं। तो वी विल स्टार्ट फ्रॉम 0 till n-1, राइट? सो I is less than or equal to n-1, or we can just simply do n. And if the element at position I is same as x, then we should print uh, ठीक है। और हम क्या करेंगे, एक बूलियन फ्लैग बना लेंगे जो कि इनिशियली फॉल्स होगा। तो अगर हमें अपना एलिमेंट मिला तो हम फ्लैग को ट्रू कर देंगे। तो फिर एरे के इटरेशन के बाद अगर फिर भी फ्लैग फॉल्स हुआ, तो इफ फ्लैग is still false, then we need to print out that the element x was not found. ठीक है, तो अभी हम 5 एलिमेंट्स का एरे बनाते हैं। तो 2, 5, 8, 9 और 11। तो enter the element you want to search. So if we search for 5, the element 5 was found at position 1. As the arrays are 0 based index, so 2 will be at position 0 and 5 will be at position 1. Okay, so this was the linear search algorithm. Again, let's take another example. And now if we search for, let's say, 4, it will print that 4 was not found. So This is the linear search algorithm. I will just comment it out now. Okay, so let's do one more thing. Instead of using array, I will now just use vectors. Okay, so instead of declaring an array, I will just make a vector of integers named array. Okay, and then I would take element p, and then I will just push back the newly entered element. So push back p. Okay, so this is the same as previous. Okay, so now we will see the binary search algorithm. Okay, so some of you might have completed the binary search. So can someone from you please tell me what is the mandatory thing that is needed for binary search? Any one of you, you can turn on your mic. Huh. So Omkar is saying sorted array. So yes, he is right. So the first and the only condition that is needed for binary search is that the array should be sorted. So so before binary search, what I will do, तो मैं क्या करूँगा कि एस टी एल में मतलब सी प्लस प्लस की जो लाइब्रेरी है एस टी एल उसमें एक बाइनरी सर्च फंक्शन है, बाइनरी सर्च नहीं सॉरी, सॉर्टिंग का फंक्शन है इनबिल्ट, तो वो सिखाता हूँ पहले। तो ओके, सो ये फंक्शन सिर्फ ऐसा है कि आपको ये वाली लाइब्रेरी को लेना होगा, बिट्स एस टी डी सी प्लस प्लस। तो ये मतलब इनबिल्ट ही है सी प्लस प्लस में। तो आपको क्या करना है कि सिर्फ सॉर्ट के वक्त आपको वेक्टर जो है तो उसका बिगिनिंग का पॉइंट और वेक्टर का एंड का पॉइंट उसको सिर्फ आपको डालना है और फिर वो सॉर्ट हो जाएगा। तो हम उसको सिर्फ प्रिंट करते हैं। तो अगर हमने 5 एलिमेंट्स के एरे लिए और ठीक है तो वो सॉर्ट हो जाता है। और अगर हमारे पास आ, सिर्फ ये है कि वेक्टर के बजाय मतलब नॉर्मल एरे है, तो क्या करना है कि सिर्फ इधर जो एरे होगा वो होगा और उसका एंडिंग पॉइंट जो होगा वो एरे प्लस एन होगा। तो ऐसा क्यों रहता है? क्योंकि एरे जो होता है वो एक्चुअली एक इंटीजर का पॉइंटर होता है। तो उसका इफ़ यू एवर प्रिंट आउट जस्ट एरे, what it will return is that it will return the address of the beginning of the array. So what array plus n will be is that it will be the pointer to the last element in the array. Okay, तो हम ऐसे सॉर्ट कर सकते हैं। सो ओके, सो ये सॉर्ट हो जाता है। ठीक है, तो अभी इसके बाद अभी हमने एरे तो सॉर्ट कर लिया, तो बाइनरी सर्च देखते हैं। सो बाइनरी सर्च में क्या होता है कि मतलब ऑलरेडी एरे सॉर्टेड होना चाहिए। तो फिर हम क्या करेंगे कि एक फंक्शन बनाएंगे बाइनरी सर्च का जो एक एरे लेगा। तो एरे लेगा और फिर एक वो एरे की साइज का वेरिएबल भी होगा जो कि n, ठीक है। फिर ओके, n की ज़रूरत नहीं है। लेट्स टेक जस्ट लेफ्ट एंड राइट। Okay, and the element k. So what k will be? K will be the element that we want to search. Okay, so after that, what we will do is that we will just print the result that is written from the above function, right? So we are going to pass the array. The left would initially be at the index 0, right? And the right will be at index n minus 1. And the element we want to search is x. Okay, so let's see if if first what we need to do is that we need to make uh, a variable mid. So mid will be uh, right plus left by 2. So now the mid variable will have the index of the middle element. Okay, so first we need to check if left is greater than right, then we need to return -1. So this is because, see, if we had an array with values 1 2 3 4, okay, and we had started with left here and right here. Okay, so for at any instance, if left is greater than right, then it means that the element does not exist in the array, so we need to return -1. Okay, okay, so now we have the middle element. Hmm. So first we need to check if array of mid is same as k. That means the value of the middle element is k. So we can return the index. Okay, so we can just return the mid. Else if array of mid is okay, so if the value of k is greater than array of mid, then what we need to do? Okay, so let's take the example again. So here the mid will be 5. Okay, and for example we are searching for 7. So if k, which is 7, is greater than 5, then we need to search for the right half. Okay, so we would search for the right half by returning the binary search of the array starting from the mid element till the right, and we still have to search for k. Okay, and else if this is not the case, then k is less than the middle element. Okay, so we need to search for the left part. So we would just return binary search of array of left mid -1 and k. Okay, okay, so let's see if this works. Okay, so let's do one thing. Instead of right plus left by 2, let's do left plus right minus left by 2. Okay, and also as we have already checked the mid element, so what we would do is that we would just check from mid plus 1. Okay, let's see now. Okay, so when we search for 2, as 2 is at the index 1, so we get 1. Okay, so this is the recursive binary search. There is one more type of binary search. So this is called the iterative one. So what we do here is that we take the length of the array and the element that we want to search. Okay, so it will be k. Then we will similarly make left as 0 and right as n minus 1. Then while left is less than or equal to right, we will again make the mid element, which will be left plus. Okay, so then we will again check if array of mid is k. If this is the case, then we can just return the mid index. If this is not the case, then else if array of m is less than k, then we can make the left as uh, mid plus 1. So let's again take that example. Okay, so initially left is here, okay, at 1, and right is at 10. So uh, let's take let's just assume that we are searching for 7, okay, and the mid will be initially 5. So so what will happen is that uh, we will see that k is greater than the mid element. So we just need to update the value of left from 1 to 5, from the index of 1 to 5. Okay, so we just need to update the left and the right variables. So else what we need to do is that we need to make right as mid minus 1. Okay, so this was the second binary search. Okay, so does anyone have doubt till now in binary search or any other thing? Okay. Hmm. Okay, so let's move to recursion. So let's see what we can do in recursion. Okay. Hmm. So for recursion, we would what I will do is that I will teach you the Fibonacci series. Uh, so let's take an integer n. So what a Fibonacci series is that the first element is 0, the second element is 1, the third element will be 1 again, and from that, then after that it is 2, then 3, then 5, and then 8, I think. So the nth number in Fibonacci, so Fibonacci of n is Fibonacci of n minus 1 plus Fibonacci of n minus 2. Okay, so the so we got 8 here by adding 3 and 5. Okay, and also two values are already fixed, so Fibonacci of 0 is 0 and Fibonacci of 1 is 1. Okay, so the first two values are already fixed and we just need to find the next values. So so um, so we need to find the Fibonacci of n. Okay, so we will make a function to print it, which will basically return the Fibonacci of nth element. So so it will return an integer, uh, and it will take an integer as input. So if n is 0, then we can return 0 directly. If n is 1, then we can return 1 directly. Else we can just return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Okay, so let's see. If we want the Fibonacci, if we want the third element in the series, then we get 2. So the series was 0, 1. Okay, so this is the 0th. So let's see, the 0 is 0, 1, 2 is again 1. Let's see the sixth element. It's 8. Let's see the 15th element. It's 16. Okay. So this was the recursive implementation of the Fibonacci series. So does anyone have doubt till now in recursion? Okay, so recursion is over. I would just now show you how the selection sort works and then we can move to the problems. So so let's take an integer n, which will be the size of the array. Then we are taking the input. Okay, then we will make a function selection sort, and we will pass the array and the size of the array. Okay, so this will be okay. So instead of making a function, we will just implement it. So what happens in selection sort? Okay. Hmm. So first we need to iterate from 0 to n. Uh, n minus 1. Then in each iteration, what we need to do is that uh, let's again take an example. Okay, so if we have this array, so in the first iteration, what I will do is that I will check the whole array for the least element found. So after iterating the array, what I will find is that I will find that the element 1 at index 3, element 1 at index 3 is the smallest element. Okay, so what I will do is that I know that as 1 is the smallest element, so it belongs to the first position, which is at 0th index. So what I will do is that I will just swap 5 with 1. So after the first iteration, the array will look somewhat like this. So 7, 5 and 3. So in second iteration, what I will do is that I will just check uh, the remaining array. Okay, then what I will find is that the least element here is 2. So so we don't need to do anything here. Okay, so after the second step also the array will be somewhat like this. In the third iteration, I will find the least element in these three elements. Okay, so 3 is the least here, so I will swap 3 with the starting index of from where we took the array. So the starting will be 7, right? So we will swap 3 with 7. Then after that it will look somewhat like this, 5 and 7. Okay, so I think uh, this idea is clear. Okay, so now we need to iterate from. Okay, then we need to find the minimum index. So first the minimum index would be at I, and let's just start from I plus 1. Okay, so if we arrive at some element where uh, the value of minimum the minimum element in that array is greater than uh, is greater than the element at that position, so we need to update the index, the minimum index. So it will now be j. So for example, if we start from here, so I will be first 0. Okay, then minimum index will be 0 only. Okay, so if when j is at 2, right, so what will happen is that array at minimum index will be 5, which is greater than 2, right? So the minimum index will be now set at the index 1. So these are the indices 0, 1, 2, 3. So minimum index will be at 1. So after the iteration, we will have the minimum element in the array. Okay, in that particular iteration. So what we need to do is that we just need to make the swap. So I will make a temporary variable. So we need to swap array of mid index with array of I. Okay, so array of I will be array of mid index, and array of mid index will be temp. Okay, so let's take an array of size 5. Okay, so after sorting, we can see that we get the sorted array. So the time complexity for this algorithm is O of n square. The best algorithm for sorting is merge sort, which uses O of log n time. So if you want, you guys can try it yourself, merge sort. Okay. So let's now move to the problems. Does anyone have doubt in anything till now? Okay, no doubts. हॅलो, आवाज येतोय का माझा?
हो येतो.
हां,
हो हो.
ठीक आहे, ठीक आहे. Okay, so we have to implement here the binary search algorithm on Geeks for Geeks. So when I had first tried this, it was actually like this. So it was binary search. So the function call was initially like this. So it was having an array input, then the left, right, and the integer k. So a few days back, it was like this, but I think they have changed now. So uh, we need to implement the iterative binary search as we have already implemented. So I will not show it again. So uh, you guys can see the implementation here. So what the problem statement says that if the element is not found, then we should just return -1. Else if it is found, then we have to return the index of it. Okay, so I will just run this. Okay, so this is done. Let's see the next problem. So Tower of Hanoi is a very important problem, and the thing is that uh, I think it is almost impossible to just explain it in a editor. So what you guys can do is that there is a good video. I will just send you the link. So in this video, they have a good graphical representation. So you guys can check this video out, and then you can try implementing the code. So uh, try this problem yourself. Okay, so I will just move to the next problem. Okay, so given a sorted array of distinct integers and a target value, return the index if the target is found. If not, then return the index where it would be if it were inserted in order. Okay, so we have been given an array and we have to uh, return the index if the target is found. Else, if not, then we have to just return the index where it would be in the array. Okay, if it was there. Uh, so the first idea that comes to anyone's mind is that we just will make an index I as 0, then while I is less than n, and so if array, okay, so we have nums. If nums of I is still less than the target, then we should move forward, right? So let's take this example. If we had 1 3 5 5 1 3 5 and 6, and we started with I at 0, so these are the indices and these are the values at that array. So we will start from I is equal to 0, and while the value, which are these, is less than the target, we have to move forward, right? So we will start from 0 and we are searching for 5 here in the first case. Okay, so what we will compare is that as 1 is still less than 5, we will move forward. So I plus plus, right? So I will be now 1, then as 3 is also less than 5, I will be now 2, and the loop will break now because nums of I is same as target. So we just need to make I plus plus and then return the value of I, as I will be the index that we want to return, right? So we just need to return I. Hmm. Let's try to submit this. Okay, so n will be the size of the array or the vector. Okay, so the runtime is 8 milliseconds and it's faster than 66.696% of C++ solutions. So can anyone think of some improvement in this program? Has anyone actually uh, tr- tried this? You can put it in the chat box. Okay. Okay, so I will just tell you. So as the array is sorted, so instead of just linear searching through the array, what we can do is that we can just implement a binary search, and it will drastically reduce the time complexity of the algorithm. Okay, so let's see. So we will make a variable left which will be 0 initially, and right which will be n. So we are taking n because sometimes it may happen that we have an array like this, and we are searching for element 7. So what will happen is that 7 will be inserted at the position n, right? So uh, this is 0 1 3. So 7 will be at position n, which is 4. Okay, so while left is less than right, we will make a mid element which is left plus. Okay, so okay, so we now have the mid element. So if uh, nums of mid is greater than or equal to target, then we need to search for the left side of the array, right? Because uh, the middle element is greater than or equal to target. So for example, if we had again this and mid is 4 and we are searching for 2, right? So the mid is 4 which is greater than 2, so we need to search for the left subarray. So to search for the left subarray, what we can do is that initially left was here, right was here, and this was mid. So what we can do is that we can make uh, right as mid. Okay, so we would just do right is mid, and if this is not the case, then we can just make left as mid plus 1. Okay, so and if this loop breaks, so left will be the position where we want to insert our element. Okay, so I think we should try to submit it. Okay, so this is also 66.96% faster than other people. Okay, so this question is done. Let's now move to the next one. हॅलो, आवाज येतोय का रे खरं? अजिंक्य,
आ रहा है गौरव।
येतोय येतोय.
येतोय का? कोणीच काही बोलत नाही राव. डाऊट्स नाही का कोणालाच? अजिंक्य, श्रावणी, अच्छा, रोशन. नावं घेऊ का एक एक करून आता?
नहीं डाउट्स नहीं है ना, इतना अच्छा समझा रहे तो कैसे होंगे.
अच्छा,
सही
ठीक
है
है.
यार गौरव, क्या प्रॉब्लम है? कोई प्रॉब्लम नहीं है.
ठीक है, तो जाता हूँ मैं आगे. सो
एटलीस्ट ऐसी
नेक्स्ट
ऐसी ही
क्वेश्चन
जो
इज
है उन लोगों को ज्यादा डाउट्स होने चाहिए.
हम्म ठीक है. तो द नेक्स्ट क्वेश्चन इज सर्च इंसर्ट पोजीशन. ये तो हो गया अभी. Hmm. So in this question, what they have asked is that they have given you an array, and in this array, there are some numbers. Okay, so from these numbers, there is a single number which is occurring more than uh, the half size of the array. Okay, so n is the size of the array, and there is a element which is appearing more than n by 2 times in the array. Okay, so I will just comment this out first. So what's the first thing that comes to anyone's mind is that we can make a map or a hash map in Java. uh, okay, so we can make a map which will be an integer to integer map. So for those people who don't know map is the I will just explain you. So what map is that it's a container which is implemented in the STL library of C++. So what map does is that it stores uh, it stores the number and some count. Okay, so what we can do is that we can just assign some number to hmm, uh, so for example, if I put here 4 and here 6, then what it will do is that it will just store the values there. So for example, I have 9 here and 10 here. So if I print out something like this map of 4, then what it will do is that it will just print out 7. Okay, so these are basically key value pairs. So the keys here are 4 and 9, and the values are 7 and 10. Similarly, in Python, you guys have the dictionary, right? So map is same as dictionary. In Java, I think there is hash map or yeah, something like hash map. So you guys can use hash map also. Okay, so we will have a map. Okay, so we will just iterate through the array, and what we will do is that we will just increment the value of that element by 1 plus plus. So what will happen is that let's say for example we had this array. Okay, then after iteration, the after the first call, the map will have the value 1, uh, means this is the key and this is the value. Okay, so when okay, so what I will do is that I will just make this more clear. So when we will start the iteration from 1, the key 1 will have the value of 1. Okay, so then after the second, when we arrive at 2, 2 will also have the value of 1, because when a new element is created in a map, it is assigned a value of 0. So after assigning a value of 0, we are incrementing it by 1, right? So these will be 1 1. Then after that, when we arrive at 3, it will also have 1. Then we again arrive at 1. So what will happen is that this value will get incremented by 1, right? So it will be 2, and then we again arrive at 1, so this will become 3, right? So we will just increment their values, right? So now what we need to do is that we just need to check the map, and we need to see if a single key's value is greater than uh, the size by 2, right? I will just comment this out. So after the iteration, we just need to see if a single value here is greater than the size by 2. So here we have size as 5, right? Size is 5, and 5 by 2 is 2 only, because it's not 2.5 in C++, because it's an integer, right? So integer of 5 by 2 is 2, and they have said that the majority element appears more than n by 2. So if the if anywhere we find a value which is greater than 2, then we should return that key for it. So for example, here we have found 3 which is greater than 2, so we need to return 1, right? So what I will do is that I will just iterate again.
Gaurav, they are asked also in whether n by 2 is seal or floor, no?
वो ऑटोमेटिकली फ्लोर होता है.
चलेगा, हाँ हाँ, ठीक है,
सो
इंटीजर ही है ना।
तो हमें क्या करना है कि इफ p of okay, so if we find some element whose key is greater than num size by 2, then we should return the element, right? Okay, so also they have said that the majority element always exists in the array. So we are sure that we will find the answer. So let's try to run this. Okay, so let's just return 0 here. Okay, so we have a solution which is faster than 35% of people. Uh, okay, so there is one more approach.
तो
Hmm.
या अथर्व उनको ये गौरव ने ये भी पूछा, मतलब अगर मैप की जगह अनऑर्डर्ड मैप यूज करते तो फिर
Hmm.
बेटर होता है ये अप्रोच.
So you guys can also use an ordered map. Let's see how much time complexity it gives. Okay, so now we have 45% faster than other people. So there is one more approach for this problem. So I will just delete this. So okay, so this is a algorithm. I don't remember its name. This was invented by someone. I don't remember his name. So what happens here is that we will have a variable which will be count, and we will just iterate through the array. And what we will do is that we will see if the current element is the element that we want to find. Okay, so what I will do is that I will show you the explanation here. It's actually really hard to explain this approach. So actually this question has about 4 to 5 approaches. You guys can check it out in the solution section of it. Okay, so so this approach is called Boyer-Moore voting algorithm. So what happens here is that uh, we would we will take some element. So for example, if we start from 7, uh, we will increase the count by 1, and the current element that we are finding is 7. Okay, so when we encounter 7 again, what we'll do is that we will just increment the count value by 1. Okay, so now we arrive at 5. So we were actually looking for 7, right? So what we need to do is that we just need to decrement the value of count by 1, right? So then we again arrive at 7, then we will add 1 to the count, then again subtract 1, and again subtract 1, right? So if at some time the count becomes 0, right? So for example, if you had array somewhat like this, 7 7 5 5, right, and then 3 3 3 3, then we will start from 7, and we will try to find if 7 is the maximum occurring element in the array. Okay, so uh, here count will be 1, right? Here count will be 2, then here it will get decremented, which will be again 1, and here it will be 0. So when it becomes 0, we need to update the element that we need to find, right? So we will now need to find 3. So after that, the count will be 1, 1, 2, 3, and 4, right? Okay, so this is the basic gist of the algorithm. What I will do is that I will just send you one more clear explanation for it.
गौरव इसकी कॉम्प्लेक्सिटी क्या है? ऑर्डर ऑफ n ना?
Huh. This is the fastest algorithm for this problem. So, so what current element is that it's the element that we are currently checking. Okay, so if count becomes 0, then we update the current element to the uh, element at the current position. Okay, so it's actually really hard to understand unless you read this whole thing. Okay, so just refer the link and try to understand. The implementation is actually really easy, so you guys can see this. So I will just submit. So this is the fastest algorithm for this problem, right? It uses O, it uses O of n time and O of one extra space. So it does not use any extra space, right? So this was it for this question. Let's now move to the next. Okay, so in this question we have been given an array, and in this array we just need to find if there is a element which is repeated. Okay, so for example, here 1 is repeated, here not a single element is repeated, and here also we can find the repeated occurrences of elements. So the first thing that comes to anyone's mind is that we can make a set, right, of integers. Then we can just iterate through the array or the vector, right? Then we will just so for at any instance, if we find the current element, so if set dot find I is if it's not found, then what st dot find I will return is that it will return a pointer which is pointing towards the end of the set. So this will be true when if if the element is not found, right? And if the element is found, this will get executed. So when we are at any position and if we find that element, uh, so we can say that it has previously occurred in the array. So we can say that the array contains duplicate numbers, right? So if element is not found, then we can just insert the element in the array. Okay, and if the element is found previously, then we can just return true. That means, okay, I will just explain again. So let's take this example, 1 2 3 and 1. Okay, and now we have our set here. So we will start from 1 and we will first see if the set already has one. As it does not, so as element is not found, we will insert I, which is 1. Okay, so we will insert 1 in the set. Now we move to 2, right? So we will again search if 2 is present in the set. As it's not, so we will again have to insert 2 here. Similarly, when we arrive at 3, we will see if 3 is already present in the set. It's not, so we will again put 3 in the set. Now when we arrive at 1 again, uh, this will be false, so st.find I will return a pointer towards this element. Okay, so the element was previously in the set. That means that the element was somewhere in the array before. Okay, so we can say that there is some repetition of elements, so we will return true. If this was not the case, let's take 4 here. So what will happen is that 4 will again get inserted, and this clause will never get executed, right? So we will come here and return false. Okay, so this was the solution for this. Let's try to submit. So this solution is just 23% faster than other people. So okay, can anyone think of any other approach to this solution? इतना तो समझा कि नहीं, वो तो बताओ चैट में, जितना बताया अभी. ओके, सो इतना तो समझा. ठीक है, तो इसके लिए और बहुत सारे अप्रोचेस है. आई थिंक 3-4 अप्रोच हम ढूंढ सकते हैं. सो इसमें और एक हम चीज़ क्या कर सकते हैं कि सपोज वी हैड एरे लाइक दिस. ओके, सो अगर हमने इसको सॉर्ट कर दिया तो ऐसा कुछ तो भी आएगा 1 1 2 2 2, right? So if we sort this array and then we iterate through the sorted array, so 3 4 6 2. Okay, so if we iterate through the sorted array and if any two neighboring elements are equal, then it means that there is some repetition in the array. So what I will do is that I will just use the sort function on the array, right? So on the vector. ठीक है, तो सॉर्ट करने के बाद हमें क्या करना है कि we just need to check the neighboring elements. So if array of I is equal to array of I plus 1, if this is the case, then we need to return true, else we have to return false. Okay, so let's try this.
कारो
Okay,
बाउंडिंग
so n
कंडीशन
is,
रॉन्ग है. आई इज लेस देन n-2 होना चाहिए.
हाँ नहीं सही है वो, क्योंकि i-1 जब होगा तो ये देख 0 1 2 3 4 5 और n is 6, right? So हमें आई को सिर्फ 4 तक ही लेके जाना है, क्योंकि जब हम 4 पे हो गए तो हम इंडेक्स 4 और 5 को ये करेंगे कंपेयर। उसके बाद अगर तू मतलब इधर आया, अगर इसको सिर्फ ये किया nums डॉट एंड, तो क्या होगा कि तू 5 पे आएगा और तू 6 की वैल्यू एक्सेस करेगा जो कि आउट ऑफ बाउंड्स हो जाएगी। समझा?
अरे हाँ 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 हाँ, ठीक ठीक ठीक।
क्या हुआ?
लेस देन इक्वल टू होना चाहिए था।
नहीं नहीं, सही है। अरे क्या प्रॉब्लम है इसका अभी? 1 मिनट रुक। We will just make a variable nums dot big size, and we will use that here. Okay, so as you may know, the sort function uses O of log n time. Okay, so the runtime of this algorithm is O of log n, and for this loop it will take O of n time. So as O of n log n, sorry, n log n. So the runtime of this algorithm is O of n log n. Okay, so this is faster than 90% of the people on lead code. Uh, okay, so I think you guys got this. I will just now move to the next problem. Okay, so given a non-empty non-empty array of integers, every element appears twice except for one. Find that single one element. Okay, so there are many approaches for this. So the first approach that anyone can think of is that you can make again an unordered map of integers. Then what you can do is that you can just store the count of the elements. So for example, if we had this array, okay, then we will have key value pairs. So after iterating through the array, key 4 will have value as 1, key 1 will have value as 2, key 2 will have value as 2. Okay, so this will be possible because we will just do like this. So int I in nums, we will just increment the count of I by 1. So after that what we can do is that we can just iterate again. Okay, then we can check if map of I is 1, right? uh, so what the question asks is that there are some elements in the array and all of them are repeated, like all of them are occurring twice except for one. Okay, every element appears twice except for one. So if the value is 1, so if the count is 1, then we can say that 4 is occurring just once in the array. So we can just return I, right? So this was a solution. Let's comment this out. Okay, so this works. Let's try to submit. Okay, so this is just faster than 18% of the people. So let's see some other approach. So uh, one more approach that one can think of is that uh, you can maintain a set. Okay, so first iterate through the array uh, int I in nums, then okay, okay, so let's just, so what I will do is that I will just show you one more solution. Just wait a minute. Okay, so there is some mathematical solution for this also. So as we have all the numbers, so let's take this a. So let's take this example. If we have this array a, b, b, and c, then if we find this expression a plus b plus c minus, then we are so so the remaining value from this expression will be c, right? So so to find this, what we can do is that we can have a set of elements and we can insert all of the elements in them, and as in a set what happens is that if we insert multiple values, it will store just one occurrence of it. Okay, so we can maintain a set for this, and this is basically the sum of the array. So what we'll do is that we will have a set of integers. We will insert the I, then we will have some numbers. Okay, so let's make this x and minus y. So what y is that it's just the summation of the array. So y will be 0 initially and x will also be 0. So first, as we are inserting here, what we'll do, we will also add the value to y. Okay, so y plus equals I. So we now have the sum of the array in y. So we just need to find x. So for int I in set, so I will iterate through all the values in the set, right? So I will be a, b, and c. So we need to add 2 into I, right? So because 2 into a plus b plus c is 2a plus 2b plus 2c, right? So we can add that, and in the end we just need to return x minus y. Okay, so I will submit it. Okay, so this is still just faster than 8.54% of people. So I will now explain the most efficient approach here. So you guys have studied what XOR is, right? So the XOR table is somewhat like this. So for 0, so this is A XOR B, okay, and this is B. So 0, 1, 1, 0. So 0 XOR 0 is what? Is 0. Okay. So XOR is exclusive OR, right? So XOR of 0 and 1 is 1, 1 and 0 is also 1, and 1 and 1 is also 0. Okay, so the integers that are stored in the array are in the format of bits, right? So for example, if we have 5, so 5 is represented as 0 0 0 0, uh, then we have 1, then 0, and then again 1, right? So this is the binary representation of 5, and in any integer, so the int data type has 30 is 32 bit, so this will be 32 bits total. Okay, so now currently we have 18 bits, so it will be somewhat like this. Okay, so we will have 5 here. Now there are some properties like if I have any number like 15 or 20 or 30, like anything, so A XOR A is always 0, A XOR 0 is always A, and 0 XOR 0 is always 0. Oh, 0. So we will use this property. So what will happen here is that uh, for example, if we have array somewhat like this 4 1 2 1 2, then what will happen is that the bits of 1 and 1 will cancel itself. So what we are going to do is that we are just going to find the exclusive OR of the whole array. So we will have integer answer which will be initially 0, right? Then we will just iterate through the array, through the vector, and we will just make answer is equal to answer XOR I. So what will happen here is that when 2 and 2 will be taken in the loop, right? So what they will do is that they will cancel the effect of each other. Okay, and then what will happen is that this 2 will cancel the effect of this 2, this 1 will cancel the effect of this 1, and what we are remaining is that 0 XOR 4, which will be 4 only. So we are just with the last element, which is not a duplicate. So the answer will just have the element that we need. So we will just return the answer. So let's see how much fast is this. So this is also 47% faster. So I think that there is no more method to get a more fast solution than this solution. So yeah, so this was it. So let's move to the last question. So contains duplicate 2. Okay, so given an array of integers and an integer k, find out whether there are two distinct indices I and j in the array such that nums of I is nums of j and absolute difference between I and j is at most k. Okay, so for so let's take uh, okay, so let's have this array, and if we have k as 4, so what they are saying is that you need to find some element, you need to find two indices I and j, such that the numbers at both the indices are equal, right? So nums of I is same as nums of j, and the absolute difference between I and j is at most k. So the difference between the indices is at most k. So here, if you take this one and this one, the difference between their indices is more than 4, right? So there are more than 4 elements between them. So the only possible pair here is 3 and 3, as there are just 3 elements between them. Okay, so this is the question. So what I will do. Okay, so what we can do is that we can make again an unordered map or a map. Unordered. Okay, so also people who are using Python or Java, you can use the Python dictionary. Okay, and in Java you can use the hash map. So we will have a map of int and int. Okay, so we will have a map of int and int, and then we will iterate through the array. Okay, now what we need to do is that we will take x as nums of I. So x is the current element that we are at index I. Then I will have not hmm. So what we'll do is that we will just store the recent calls of the uh, occurring elements. So for let's okay write that. Hmm. So what this map will store is that if we find for map of 3, what it will store is that it will store the most recent occurrence of 3 in the array. So when we start iterating the array, first we will be at here, right? So this is at index 2, right? So first map of 3 will be 2. Then as we move forward, the map of 3 will get updated to uh, 4. Okay, because this is the most recent occurrence of 3. So we will find x in the map. Okay, then if iterator is equal to uh, mp dot end, then this means that the element was not previously in the array. So what we will do is that, okay, so if it was not in the array, we will not do anything else. If it was found, then if so let's just do this. So if it was not previously in the array, so if it was previously found in the array, then what we need to do is that we just need to check if I okay, so mp of x is I. So okay, so what this statement does is that whenever we will arrive at any element, we will update the most recently found element as the index there. So this will be 6. Okay, so when we will arrive here, the map of 3 will point to 2. Okay, so MP of 3 will be 2, right? And MP, and when we will arrive at 4, then MP of 3 will become 4, right? Because this is X and this is I. Okay, so we are making MP of X as I. Okay, then what we are doing here is that if we find the element, okay, if the element is found previously, so when we will arrive at 4 and we find the previous occurrence of 3 at 2, then we will subtract the previous occurrence with the current index, right? So I is now 4 and the previous occurrence of 3 was at 2, right? So iterator dot second are these values, these values 2 and 4. Okay, these so X is the key and I is the value, so iterator dot second is the uh, value. Okay, so if we find some previous occurrence, then we will just see if the difference between them is less than or equal to k, is at most k, right? So if this is the case, then we will return true, else we will return false. So I will just run this. Okay, so this is faster than 77% people. So yeah, so I think this is done. So does anyone have any doubt? Okay, so how many of you have not started with week 2 or started with week 2? You can just put it in the chat box. Started or not started? It's okay if you have not started it now. Okay, so hmm. Okay, so in week 2, I think you have the implementation of linked list and that. So let me just see the portion. Okay, so in week 2 you have visualizing the linked list and its operations, then search operations on linked list, then circular and doubly linked lists, and some more stack problems. Okay, so anyways guys, I hope your all doubts were cleared and you were able to understand what I had taught today. So Sunanda, Ahika. Hmm.
टॉवर ऑफ हनायचा व्हिडिओ आपण प्ले करू शकतो का, म्हणजे कळेल मस्त आहे का?
करतो करतो मी दाखवतो, पण काम आहे थोडं, मला मी थोड्या वेळात जाणार आहे. दाखवतो मी व्हिडिओ, असं काही प्रॉब्लेम
नाहीतर
नाही.
आपण ग्रुपवर लिंक सेंड करू ना, म्हणजे जे मीटिंगला नाही येत ते पण बघू शकतील.
ओके, चालेल.
ठीक आहे, मी टाकतो मग ग्रुपवर.
असं मग भारी झाला सेशन, भरपूर पॉइंट्स कव्हर झाले. गाईज
आणि
वीक
बोलत
टू
जा यार,
स्टार्ट.
कोणीच बोलत नाही. काय तुम्ही स्टार्ट नसेल केलं किंवा सॉल्व्ह पण नसेल केलं ना, काही प्रॉब्लेम नाहीये. इथं काय आम्ही टीचर वगैरे नाहीये, तुम्हालाच शिकायचं आहे. तुम्ही अजून वीक 1 पण नसेल स्टार्ट केलं तरी ठीक आहे, सांगत जा फक्त.
हा, करू कव्हर.
हम्म.
तुमचा जो काही फीडबॅक आहे क्लिअर द्या.
हम्म.
कम्युनिकेशन क्रिस्टल क्लिअर असलं तर मग प्रोग्रेस
खूप
व्हायला
हार्ड
सोपं जाईल.
असेल किंवा खूप फास्ट असेल ते पण सांगा. ठीक आहे, मग चालेल.
कुणाला बोलायचं आहे का काही, नाहीतर आपण मीटिंग एंड करू. ओके मग चालेल. गौरव
ठीक आहे.
थँक्स.